Hello and welcome. In this video, we are going to take a look at the final case from the online rounds of the 2025 Microsoft Excel World Championship called It's Probably a Crab by Nick Boberg. Allow me to read the instructions. You are at the seashore hunting for crabs. Crabs like to hide under rocks, as do other types of marine life. The probability of finding a species of marine life under a given rock varies based on the tide, with species more or less prevalent at high and low tides. The tide cycles are 2 times 6.5 hours long, so going from high tide to low tide back to high tide again. The probability of finding marine life in between tides is linear based on the respective probabilities for high tide and low tide. For example, the probability of finding a crab under a rock at 3:15 a.m., half tide on day 1, is 55%, midway between 80 and 30%. Happy crab hunting. That's all the pretext that we have for the case. We are going to look at probabilities for finding various marine life either in low tide or high tide or somewhere in between. So let's go ahead and follow along with me as we give this case a shot and see how long I can get a complete solve. Here we go. All right, so before I start looking at the questions, first thing I'm going to do is this looks like this has some good information. So I'm going to turn these into tables. Whoa. Okay, so let's turn this first into a tide table. So we're going to call that tide. Let's go name and time there. Now, one thing I want to take a look at is because this is day 2 at 2 a.m. Now, time is usually represented as a fraction of a day, right? So I think what I want to do, what happens if I do this? So if I do this plus time, 6 hours, 30 minutes, and 0 seconds, I think this 2 o'clock is going to be different because that's going to add a value of 1. So I'm going to put those values in there instead. Yeah, see how that says the first instead of just the time? All right, and then let's turn this into a table. So let's call this, instead of marine life, let's just go ahead and call it, let's call it animal. Animal. And here we're going to go with name, symbol, and then we got low tide and high tide. I like to do that first because we have the data right here and it's going to be easier to reference as we type in our formulas. So let's go ahead and take a look at level 1. Assume it is high tide. Calculate the probability of finding both of the following types of marine life under a given rock. All right, so we're going to find the probabilities under high tide here. So let's go ahead and let's look up these symbols. Animal symbol, return animal, high tide. So that gets us the probabilities within high tide. Let's go and take the product of those two together. And in the instructions, it says, if you were doing this 10,000 times, how many times would be likely to find both creatures? So we're going to take that product and multiply it by 10,000 times. We're going to get 875. Just to be safe, I don't remember if it's this level, but I'm going to round this to 0 digits because there were decimals involved. And I don't trust Excel with decimals. There you go. Level 2. Given the following times of day, all times are AM and on day 1, how long is it until the start of the next tide phase? Express your answer in minutes. So let's take a look at our phases here. So the next high tide is at 1 p.m. Is that the next high tide? No, the next tide phase. So it could be this time or it could be that time. So I think what I'm going to do is I'm going to first look up the next tide phase. So we're going to Excel up this in animals, or no, not animals, tide time, return tide time, but return the next one. So it looks like a fraction. It looks odd. If I just do Control-Shift-2, then we're going to get a time there. And because the question is asking express your answer in minutes, let's go and take that. We're going to subtract the original time there. So that's going to tell us how much hours and minutes are in between. So 109 minutes is 69 minutes. That's correct. Once again, time is a fraction of a day. So if I multiply this fraction by 24, I get hours. If I multiply it again by 60, it's going to give me minutes. And it's going to give me 69 minutes. So let's go ahead. And then once again, because we're working with fractions, I'm just going to play it safe and round to 0 digits. There was one of these questions, I forget if it's this one or a previous one, that it didn't like doing the math and it gave a really weird answer. So rounding to 0 digits is a safe way to prevent that. Level 3, given the following times of the day on day 1, find the probability of finding a crab under a given rock. If you were looking under 10,000 rocks, how many times would you expect to find the crab? Round your answer to the nearest integer. All right, so we're given a time of day, and that time is likely going to be in between different tide phases. Ooh, so we're going to need to figure out what the tide phase is, find out how much time we're within that phase, and then use that to calculate the probabilities. So we're working with crab. So we're always going to go between those numbers, but like if we go from high tide to low tide, we're going from 80 to 30, but then if we go from low to high tide, we're going to go from 30 back to 80. So it's going to be important to tell which tide phase we are in. So I'm going to go tide phase first. I'm going to X up this in tide, time, return tide, name. I should probably call that phase, but right. And then we're going to look for this time the next smaller item. I know Excel said next larger, but I put a -1. That should be next smaller. Let's call this phase, just so that's easier to remember. All right, so we're going to get low tide day 1. Actually, you know what? Let me get rid of the day 1 here. So let's just add another column, phase. And let's go everything before that parentheses. There we go. And if I go back here, now I'm going to, excuse me, return tide phase instead of tide name. So we get low tide. All right, and then let's go phase start. So let's see, that's going to be index animals. The row is going to be based on the crab. And I think the crab is on the first row, so I think we just put 1 for row number. And then column numbers, we need to match this. Yeah, so let's see here. All right, so the columns do say low tide, high tide. So we need to match this against headers. Oops. Animal headers. Now, if I did that right, then I should get for low tide 80%, high tide 30%. This is low tide. Ooh, that did not work. Oh, the column number should be X match. X match that against the headers. Did not work. Oh, it's not animals, it's animal. All right, so low tide 80%. Let me just check that. Yes, that is working. Okay, so, and then phase end is going to be, I'm going to take this, but instead of X matching low tide, I'm going to X match if that equals low tide, then X match high tide, otherwise X match low tide. All right, so phase start 80%, phase at 30%. Sorry. Now I need to figure out how far into that phase I am. So into phase, let's see here. Okay, so here you're now 173. I'm guessing that's minutes. Yeah, so we're 173 minutes into that phase. So I need to do a similar calculation that I did up here. So I need to figure out how many minutes into the phase I am. So I'm going to take this minus X, well, X lookup, this in tide time, return tide time, but the one before. So that's, okay, so that's how far into the phase I am. Yeah, multiply by 24 and 60. That should give me the number of minutes into the phase. Right, I got 173. So that matches the example there. And then, because each phase, if I go back to the instructions, each phase is 6.5 hours long. That is 6 hours is 360 minutes. That is a total of 390 minutes. So to figure out how far into the phase I am, I'm going to divide that number by 390. I get a percentage, 44%, 44.35897. I think that's matching. All right, and then now we're going to get the probability. So the probability is we are going to start at our phase start plus 43% times the difference from the end of the phase to the start of the phase. That's going to give us a negative number, which is correct because we're going to decrease the probability as we are going on. And that's going to get us a number of 0.5782. That's our probability. Now we're going to look under 10,000 rocks and round that to 0 digits. So we get 5,782, which does match the example answer there. So let's go ahead and fill it in for all of the other questions. Excellent. Level 4, given the following times of day on day 1, calculate the probability of finding all of the following species under a rock. If you were looking under 10,000 rocks, how many times would you expect to find these creatures? Round your answer to the nearest integer. And looking at the example here, what they're doing is they are multiplying the probabilities together at that time. Okay. I could do it over here. It's probably going to repeat a lot. Let's just go to a new sheet. I think this was level 4, was it? Yes, it was. Okay. So let's go take this information over to level 4. G to J. Okay. Now, phase. So is this high tide or low tide? Let's take this formula and put it in here. Okay, so it's high tide, so that means next phase, if this equals, come on, high tide, then return low tide, otherwise return high tide. Okay. And now let's check out the probabilities of finding these in the current phase. So let's do index animal. It's only singular. Row numbers. We're going to X match these against animal symbol. Yep. And then for column number, we're going to X match these in animal headers. There we go. So that's going to give me the probabilities across all of these times. Now let's do percent in phase, and that's going to be the same formula here. So let's go ahead and move that into there. That's a time in phase. Should be a percent in phase. Oh, right. Let me turn that into percent. So I get 15.9%, and I don't have a way to check. But what I can do is I could check these percentages here. So we're going to start with these plus this percent of the difference from the end to the beginning. All right, now let's see, do these match up? 32.95. Well, let's do 9487, 352308, 31. Yes, okay, these all add up. And then the answer was just the product of those three numbers, all of them multiplied together. We are going to get 3.60%. Looking under 10,000 rocks, we're going to get that and then round to the nearest integer. 360. All right, all right. Let's go ahead and bring these numbers in. Wait a second, is that the right case? Yeah. Run the data table. Oh, 79 and 80. What happened to those? Ah! There's only 2 marine life species. Nice little trick. Nice little trick. So here I'm going to do, let's do if error, return 1. There we go. Now we're going to get an answer for those last 2, and everything checks out. All right. Level 5. Given the following times of day on day 1, what is the probability of finding the following exact selection of species under a rock? Remember to consider species not found under the rock too. If you're looking under 10,000 rocks, how many times would you be expected to find these creatures? Round your answer to the nearest integer. So for some of these, we need to consider the probability of not finding some of these creatures, as well as the probability of finding some of them. So let's go ahead and get our setup going. Let's look up this. G to M now. And then found. That's going to be a simple match those symbols against those. So we do find a crab, we do find this, we do find this, but we don't find that. Right, okay. And then, actually, you know what? Let me bring this down a bit. Oops. Bring it down here. Because I think what I can do is, can I bring those over? How bad is that going to ruin things? That worked. That worked. Actually, not too bad. And we're going to take this, we're going to match these animal symbols up there. Very nicely, very nicely. This, we're just going to extend these out. So this should be H to M. Oops. H to M, I think that's all working well. And then probability, so if this is true, then take these, otherwise take 1 minus these. Oops. And the reason we're taking 1 minus these is because the probability of not finding it is simply the flip side of the probability of finding it. So here we get, like, this is false. There is a 37.9% chance of finding, 62.05% chance of not finding. And that matches with the number up there. So let's go ahead and take the product of these numbers. We get 0.013487 under 10,000 rocks. 135, round to the nearest integer. There we go. All right, let's bring these numbers in and run. Oh, visual glitch. You see where what it highlighted is not where I clicked? Yeah, that's always fun. All right, these all check out. Excellent. Let me just delete these data tables so they're not recalculating. There we go. Level 6. How long after the high tide would you have the highest probability of finding the following exact selection of species under a rock? Remember to consider the species not found under the rock too. Express your answer as a number of minutes after high tide. For example, 0 a.m. would be expressed as 0, but 10 a.m. would be expressed as 1:30. Now, the thing I like about this example is that they highlighted 0, which means 0 could be an answer. So let's go ahead and we're going to do the same thing as we had for our previous model. G2L. Excuse me. Still coming over that cold. I know it's been a while. And we're going to bring this, but there's no time this time. So if I bring it here, right, I don't have a phase. So this is how long after high tide. So let's put high tide up there. All right. All right. And then it's this part that I'm going to have to do a nice long table for. So I said earlier that a phase was 395 minutes. So let's do a sequence. I'm sorry, 395, 390. A sequence of 391 rows starting at 0. There we go. And that's going to be the number of minutes. And this is going to be percent in phase. So it's going to be all that divided by 390. So that's going to give us all of our percent in phase. And I just realized I want these to line up. So I'm going to delete one column there. Did I delete too much? Maybe. There it goes. Now it's working. And then what I want to do, we're going to start with high tide times that. What, that's plus, not times. Plus that times the difference between the low tide and the high tide. That's going to give me my percent. So I'm going to, let's do this in let's see. So what percent equals that? If this is true, then return the percent. Otherwise, return 1 minus percent. So remember, 1 minus percent is the chance of not finding whatever item there. So there's the percentages that we get. Actually, can I just change this to that entire column? I can. All right, that was fun. And then over here, let's do by row. And once again, let's do, oh wait, I didn't highlight the right one. This one, product. There we go. So now we're getting percent. So we get lots of decimals in there. There we go. And what is the highest probability? So, or how many minutes is, okay, so we're gonna look up the maximum of this in this, return the sequences. So we can sequence as a number of minutes. I have 197 minutes. That matches the example there. So let's run this through. Yay, it clicked right this time. And you see there, if you didn't know, if you noticed, there are a few zeros. There are a few zeros. All right, green checks marks, everything checks out. Let's go to level 7. Now you are targeting specific creatures. Turning over 1 rock per minute, starting at the following start times. How many rocks would you need to turn over to have at least a 99% chance of finding the targeted species? Okay, so a very different question. I just realized I didn't delete that data table, but woof, very interesting case. All right, so let's do a level 7 sheet. Bring in all of our info. Let's do XLOOKUP that. G to H this time. Now see, what you're looking at when you look at the instructions is we have the probability of finding a crab at this time. We also have the probability of not finding a crab at this time. And what we need to do is we need to multiply the probabilities of not finding it, and eventually that's going to get below 1%. Yeah, 1%, and that's when the chance gets above 99. So let's do a sequence of, again, 391 starting at 0. And now the time. Oh boy. So the time is going to be the starting time plus 1 minute every time. So that's how we're going to do that. So you see it's increasing by 1 minute every time. Ooh. Start phase. Actually, just do phase. Let's see. Did I call that table tied? Yes, I did. Time. Return tide phase. Find the previous one. All right, so we got high tide. Now see, what happens is eventually it's going to go from high tide into low tide. And so I wanted to highlight when that change is made as well. All right, and then let's do percent into phase. So we need to find out the previous time and find out the number of minutes difference. Okay, so once again, find that in tide, time, return tide, time, but the previous one, so that's when the tide starts. Let me just return it there. So it starts at 1 o'clock. So we need to find the difference there. So that's a difference as a fraction or as a percentage, you could say. But we need to turn that into minutes. So we're going to multiply that times 24 times 60. Let's do that. Oh, that's weird. Oh, wait, no. Okay, so yeah, that's how many minutes. Okay, yes. That's how many minutes into the phase. Divide all of that divided by 390, which is the length of a phase. How did all that turn into... Oh, interesting. That was very interesting. So now we get percentages within the phase. I must have filled on the last step when I really shouldn't have. All right, so... phase start, phase end. So we're going to look up that into animal symbol return. No, it's not an X. It's going to be an X match because we're going to do a two-way lookup. It's going to be an index because we're going to do a two-way lookup. Animal row number is against the symbol. So X match that into animal symbol. And the column is going to be the phase. So X match this into animal headers. There we go. So that tells us when they start. So at high tide starts at 30%, at low tide it starts at 8%. So now we're going to do the same thing. We're going to change this. So if D25 hash equals high tide, turn that into low tide. Otherwise, turn a low tide into a high tide. So that's going to be the phase end right there. So now we got the phase end, the phase start, and the percentage within the phase. That should be everything we need to find the chance. So the chance is going to be the phase start plus 25 or 21% into the difference between the end from the start there. So that's going to be the chance. Let me just check that against the example. So at 1424, we have a 40.7692% chance. Yes, we do. And then no chance is going to be 1 minus all of those. So we should have a 59.2308% chance. Yes. All right. And then percent, or I'm just going to do answer. I know answer is not right, but what I want to do is start from 0, or no, start from 1. We can't start from 0 because we're going to do a product. Starting from 0, we'll turn all the numbers into 0. Starting from 1, using this array, do a product of all those numbers. So now we're going to get a percentage chance of not finding a crab after turning over all those rocks. The point it gets below 1% is here, which is 8 minutes into... Right, we turned over the first rock at sequence 0. So this is actually 9 rocks after we turn it over. So the way we should be able to do is we should be able to X match 1% into this array, looking for the next smaller item there. So we get 9. It's in the 9th position. That matches the answer that we're looking for. Run the data table. And everything checks out. Excellent. Let's go ahead and take a look at the bonuses. We got just over 6 minutes to go. Bonus A. At high tide, what is the probability of finding no marine life species under a given rock? Express your answer as a whole number rounded to the nearest percentage point. Right. So this is high tide here. We already know the probability of not finding an animal under high tide is going to be 1 minus all of those. Oops. Let's just do that. There we go. And then if we do product of this column here, multiply that by 100 and take it to the nearest integer, we get the answer of 12. Excellent. Bonus B. What marine life species are you least likely to find under a rock at 3:30 a.m.? Provide the full name, e.g. crab, not just the symbol. All right, so 3:30 a.m., midnight is high tide, so we're looking at a certain percentage within high tide. That certain percentage is, let's see, 3:30 a.m. That's 3 hours, 180 plus 3 minutes, 210 over 390. That is 53.84%. Okay. Let's just do bonus 2. Bonus 1. And what we're going to do is after high tide, so it's going to be high tide plus this percentage of the difference from low tide to high tide. Is that right? Oh, you did not like doing that because I didn't put a multiplication symbol in there. Now you like doing that. We need least likely to find. So we're going to do XLOOKUP 0 into this array. We want the full name. So return this name, so find the next larger item. We get a prawn. There we go. Bonus C. One of the marine life symbols occurs more frequently than the others in games numbers 1 through 140, excluding examples. How many times does this marine life symbol appear? Oh, this is one of my favorite group by questions. So we're going to do group by. Actually, we're going to let values be to call VStack. So we're looking at which levels? Games 1 through 40, so all of the levels. So we're going to get all of these symbols. No symbols there. No symbols there. All of these symbols. All of these symbols. And get all of these symbols. And then finally also get all of these symbols. VStack them together. To call is going to be ignore blanks and errors. So that's going to give me one nice big long column. And then for the calculation, I'm going to do group by V, count A from largest to smallest. I missed a column. There we go. All right, so I want to understand what appears more frequently. How many times does it appear? This one appears 45 times. There we go. Bonus D. You check under a rock every 1 minute between 12:01 a.m. and 6:30 a.m. inclusive. How many frogs would you expect to see? Round your answer to the nearest frog. Okay, let's do this on a sheet. So we're going to call this bonus, I think it was bonus C, so B4. And we're going from 12:01 a.m. to 6:30 a.m. So that's 6 hours, 6 hours, 300. Okay, so that's 390. So sequence 390. So that's how many minutes within the high tide. And so what we are going to do, let's do a percent as well. 390 there. Chance. So for the frog, we're going high tide to low tide, right? So high tide of the frog plus that percentage. Really? Oh, I think it does work. It's just the whole switching sheets. There we go. That percentage times the difference from low tide to high tide, right? Low tide to high tide. There. That should do it. So that is how many frogs I should expect to collect per minute. And then if I sum all those numbers together, I get 195.25 frogs. So round to the nearest integer. We're going to round that to 0 decimals. We get 195 frogs. Last bonus, bonus E. How many minutes after high tide gives you the highest probability of finding all 6 marine life species under a given rock? Okay, so I think what I should be able to do is if I turn all these to true, Oh, you did not like doing that. Why did you not like doing that? Oh, I think I know why you did not like doing that, because that takes it away from being arranged there. So this should be that whole range there. The highest we get here is once again at 197. Is that right? Let's check. Is it 197 again? It is 197 again. How coincidental that this answer also matches the answer for example 6. How about that? I don't know if that's just coincidental, if there's a reason behind that. But anyways, that is a complete solve of the case. It's probably a crab. Unlike all the other cases we've seen so far, we've had a lot of like map cases, a lot of visual elements to it, a lot of extra sheets. This one did not have all of that. Everything was on one nice sheet. It was a nice formulaic solve and really fun. Now, if you've not seen this case completed live, it was a really exciting match between Dim Early and Lorenzo Foti. So if you've not seen it, check out the link in the comments. I have a video to that match. You really have to watch it. It was really a lot of fun. But that does it for the online rounds of the Microsoft Excel World Championship 2025. After you see this video, you will have all 10 of my solves for all of these online round cases. If I haven't started doing so yet, next you will start seeing some of the cases that we competed on live in Las Vegas. So keep your eye out for those. I hope you enjoy watching these videos. If you do, be sure to give me a like on this channel. Be sure to subscribe. Keep an eye out for my future videos, and I look forward to seeing you for the next one.
It's the Excel World.